It's okay, we're gonna wear lab belts.
Okay, that's good. Thank you.
Okay. Also, one more thing. If I have a bonus quiz, but because we need to catch you guys up, I'm gonna hold it. But I will do it for you at some point. So if we don't get it today, remind me next time that you guys still need to do the bonus quiz. It's a good quiz because you gotta pick where the bonus points go on your quiz.
Wait, that's massive.
You always do
Except
tests.
for tests.
Dang it.
Oh.
Then lab for sure.
Lab.
So, but I'm gonna save it because I want to make sure we get through these problems
That's
first.
insane. If I just
But I don't want to forget and not do it next time. So, okay.
That's all that.
Dude, we already don't have to take a retake for the last.
Oh yeah, the last. But retakes are like good to do.
Yeah.
Okay, by raise a hand, can someone remind all of us what is pH?
No, Kimberly, not here.
You want to see. Landon, what's pH?
It tells us how much H plus or OH minus is in a solution.
Perfect. How's my face that? We'll cut. Okay. So when a problem says to calculate the pH of something, it wants to know how much H plus is floating around in solution. Okay. So for example, I have a solution up here of some 0.01 hydrochloric acid. Now we've talked about before already. What's the equation for pH?
Oh,
There you go.
pH equals something or other.
Log of the 1 times like 10 to the whatever. That wouldn't that the AKA or whatever.
Oh no, you're getting more complicated. That's Henderson-Hasselbalch.
Oh,
Oh, yeah,
dang.
that's
negative log H plus.
There you go, Isaac. Have a smiley face. So pH is just the negative log of the H plus. So you literally just need to know how much H plus there is, and then take the negative log of it. Okay?
What is negative log? Like, what does that do?
It's like a logarithm, but the
Yeah.
opposite of one.
It
Okay,
just
what's a logarithm?
changes
Oh.
because molarities are often like confusing to look at because they can be like very, very small numbers, like times 10 to the negative something. So the pH scale just shifts these weird numbers into a clean 1 through 14 scale. That's all it does. That's why the pH like doesn't have a unit attached to it. It's because it's no longer a measurement of like actual molarity, it's just a scale. So okay, so what I'm gonna do is I'm gonna pour.
What flavor is
Take a picture of that. That's magic.
It's like a multicolored sucker, and it's magical.
You see that? It's like when you get a Cheez-It that's like 4 Cheez-Its all stuck together. Or the cinnamon toast crunch is like.
Oh,
because
dude, I've got like one that's like
Yeah.
this long, man.
Whoa.
It's pretty magical.
Fascinating.
I also once got a frosted flake that looked like a sheep.
Oh my god. Wow.
Just saying.
So glad
That's
you
next
all
Yeah.
Okay, so don't say it out loud because everyone can understand my face this time.
That's hype.
Okay? But think in your head, if this is a 0.01, or maybe pull out your calculator if you can't do it in your head, what is the pH of this solution right now that I'm pouring? It's a 0.01 HCl.
Oh, feeling negative log of that. I can't do a negative log in my head, bro.
I know.
I don't even know what it does.
A log is the opposite of like an exponentially. So
I
it
type
like
it in.
10 to the power of log of log.
No, so there should be a tab at the bottom that says 2020,
1
like boys 2020 and girls 2020.
10 to the power of
Just,
log.
you'll see all the other
Or
types
like
in this
so-
year and then just
or
add
like the
them
trick is
all
it's
up.
like
And then maybe that might be another project we work on.
Yeah, if it's what?
Way out
Then
there.
it's just
log of
however many the thing is. So this would be moved over.
or no log of 10.
Wait.
So then it
Okay,
would be
does
to the
anybody know
negative
what
second.
pushing the cosine
So
button
then
actually
negative-
does? Like, what does that input?
Yeah.
Yeah, what's the
That was kind of
formula for
confusing the way I explained that.
What is
Yeah,
it?
no, I don't actually
Been a
know what it
long
does.
time.
I just know how to do it, you know?
I know how to use it.
Okay, you got 5 seconds to come up with an answer.
Like, I know how to use it, but like,
4,
Oh,
what is it?
Yeah.
2, 1. If you have an answer, show it to me on your fingers.
Wait, no, this is a different thing.
I know.
Oh, are we doing that?
No.
No, we're not. Okay, then we're doing this.
Okay, you're showing me 2. How's my face? Okay. So the pH of each of these beakers right now is at 2 because I poured in that much of the solution. Okay. Now, why could we, because I just told you the amount of HCl, right? So I said the HCl was 0.01. Why were we able to say that this is the amount of H plus 2?
I don't even know.
Perfect, Max, how to size that? It's a strong acid, and strong acids break apart completely.
Oh, because there's one.
So the amount of this
Oh.
must be the amount of H plus,
That
okay?
makes sense.
So again, this is why we memorize what's strong and weak, is it helps you with the calculation side of things. Now, here's a very similar problem. Find the pH of a 0.3 molar solution of acetic acid. The difference is though, is when it's not strong, you can't just take the negative log of 0.3 and call it the pH.
Can you calculate what that number is? Where AA, you need to use it.
Yes.
Is this the weird Hasselhoff one?
Not really.
No, that's Hasselhoff.
We'll get to that one in a second.
No, I know who Hasselhoff is. I forgot what the other.
Hasselhoff.
He's the guy that Chris
SpongeBob.
Pratt's dad in Guardians of the Galaxy
No, no.
turned into
Oh,
for a
Hasselhoff.
split second. Yeah, that's how I
Okay,
remember.
now
it.
there's something that I think didn't get printed on your notes
Yeah.
that is up here.
Where is this one?
So write down the Ka on your paper because that would be given to you. So I want you to, otherwise if it's not, you can't solve this problem. So it's the same concept where we just need to know how much H plus there is in order to calculate the pH. The difference is it's a system at equilibrium and only a small amount of this gets turned into that. So when something is a weak acid or base, you have to set up a Rice chart to find out how much is left at equilibrium.
Oh, gross.
Now what you'll find is the Rice charts get very repetitive, and so you might eventually be able to kind of skip the Rice setup because you'll know what it's going to turn into. But I'm going to set it up just so we can understand what's going on.
Rice, baby.
There's another song for our album.
Dude, that's not-
Yes. Wait,
Okay,
there's so many.
so initially I know that there's 0.30 of my acid. What else do I know? Do I know anything else?
There's.
I don't think there's any of the other stuff.
Okay.
At the
Yeah,
beginning.
in the beginning, there's always 0 of those things unless it's told to you, right? What else do I know?
Do you know the
You
results?
could do like plus X for the equal.
Why are we gonna use x's here, Nick?
It's just a variable and you can just solve for it.
Yeah, because we don't know how much it's going to change, and we don't have anything in terms of the end result, so that's where we're gonna use x's and say, well, I know this is gonna go down by some amount, because it has to break apart a little bit,
Good point.
and these ones are going to increase by, why the same amount?
Because it's 1 to 1 ratio.
Good, for the ratio, okay?
It's all coming together, man.
Because it's going down. It's
It's
decreasing.
going to
Alright, so carry that through to the end. Now, our goal, again, don't lose track of the goal, is this.
You won't remember.
Once I know how much H plus there is at the end, I can then just take the negative log of that to find my pH.
Wait, so what's the negative log of a variable?
So we gotta find the variable first.
Okay.
This is
Good question.
insanity.
So any ideas of where to go next to solve for x?
Set it equal to 1.8 or something?
There you go. What does k tell us?
Thing to thing.
Oh, comes.
It's in my head.
I always forget what
Yeah,
it's
like
Constant of the acid.
Thing to
There
thing.
you go.
Products over reactions.
So
That's it.
products over reactants.
Okay.
There. One
So-
is it?
Okay. So that's the setup for K. We know the value of it. So I'm gonna plug in, sorry, I'll give you a second to finish writing your Ka value out. Okay, so then I'm gonna get x squared over 0.3 minus x is gonna equal 1.5 times 10 to the negative 5.
Wait. Oh,
Everyone good so far?
We can cancel.
Now, you just go about solving for x. But there's a shortcut to simplify our math that we can use. You could go about solving this, but because of the x squared factor, you're gonna end up with a polynomial, which means you're gonna have to do either the quadratic formula to solve it, or graph it, one of the two. But because we're dealing with chemistry, we can actually make an assumption, because these things are not just numbers, like there's stuff behind it that simplifies it.
It makes a genius out of me and a genius out of you.
Now, with this assumption, if you were to do this on a free response question, and I recommend doing it actually every single time, because 98% of the problems, honestly, any problem I've ever seen on an AP test can be solved with the assumption. And it will save you a lot of time and possibility of just messing up little math things. But what you have to do is on your FRQs, you have to explicitly state the assumption you're making, so that people grading it can understand where your numbers went, okay? So the assumption we're gonna make is this. So we are going to assume.
You write like assume on your.
Yes, so what I'm writing is what I'd write on my test. I'm gonna assume that 0.30 minus x is just 0.30. Let's talk about why that's an okay assumption to make and what I'm claiming.
We're
Just
claiming
say that
x
x
is
equals
0.
1.
See, that's the next part. A lot of people think we're claiming x is 0, but that's,
You're claiming that a negligible amount is being broken up.
yes, I'm claiming that the chain is so
Negligible.
small, that word I can't ever say right.
Negligible.
There it is.
No way, PewDiePie can't say that either. That's awesome.
You can't say it.
PewDiePie. He has a PewDiePie. The biggest YouTuber, but anyways,
Okay, yeah.
he has a
no, you're
problem
right.
saying negligible and it's hilarious.
Yeah, I can't say that word. That's why I picked on Bryce to say it. So, what this does for our fraction though is it changes it to just x squared over 0.3 now equals 1.8 times 10 to the negative 5, which simplifies it a
That's so
lot.
much easier, because now you just times by 0.3.
Yep, and then square root it.
Nice.
Okay, plug that in and let's see if we get the same answer.
Okay, let's see.
Wait, so can we like use that like same assumption on any?
So anytime you're finding a pH of a weak acid, there's very rare cases where the assumption won't work.
Okay.
The only problem is if the assumption is not negligible, then it wouldn't work. But once again, every problem I've ever done or seen, it always works for.
Okay.
So, and especially when you're caught on time, I'd always do it that way. And then maybe if you have extra time at the end of the test, you go back and do it the long way. But so, okay, if you plug that in correctly, you should get. Where's my answer? I found. So I got x equals 0.0023.
Let's go.
And then you negative log that.
Good. Now don't get too excited because some people see like, oh, I found x, and they circle their answer and move on.
That'd be so nice if
But you
could
get
actually
0
do that.
points because that's not what they're looking for, right?
Well, actually, sometimes it might be like,
That's true.
I mean,
Maybe we'll
because like
get.
sometimes on those questions, it's like, they found this number, and then they found the actual number they were actually choosing.
So maybe you get one, but you're so close to getting all the points, right? So now we're gonna take the negative log of the H plus. And so you should have found that the pH of our solution is 2.63.
But
Wait a second.
with what's it called? With significant figures, it's just 2.6.
So I don't,
Oh no, another exception.
well, so logs have a different sig fig rule than multiplying
Dang
does.
it!
And it's just based on what comes after the decimal. So you get, since this has 2 sig figs, after you take the negative log, you get 2 sig figs after the decimal.
Why though? Why can't they just all have the same rule?
And
Because-
that's how it works.
Wait.
Okay, questions on solving this problem, any steps of it?
Yeah.
I felt suspicious doing significant figures right and her doing it wrong, and then she's like, well,
She says-
actually.
You gotta love her.
Wait
Yeah,
a
Evan,
second.
I'm just stretching.
Wait.
So this will be able, so now you can finish that 8.2/8.3 worksheet where we only did like 2 problems on before. For that. Yeah, Kevin.
So what was, I keep forgetting, but like, where you could just look at the exponent and see the pH is gonna be like between 4 and 5?
Yeah, so if we were to change this into scientific notation, so 1, 2, 3, so it'd be 2.3 times 10 to the negative 3. So this tells me that the pH is gonna be between 2 to 3.
Oh, so it's not based on that, it's based on,
It's whatever you're taking the log of.
oh.
So that was
because-
just for
Oh, that
estimating the
makes
loss
sense.
without a calculator.
So that's how much, so you can only do it based on how much H plus there is?
Yes.
So, and that's not what that is. Okay, cool.
It's like, that's
Understand it.
related to H plus, but it's not the same. So,
Yeah.
any other questions about this problem?
Yeah.
Okay, now just to finish the demo here, so, doesn't relate totally to this, but it's just cool and I wanna do it. But it does relate to what we talked about in terms of acids and bases and pH in general. So right now we're at a pH of 2, right? Okay, I'm now gonna add some 0.01 sodium hydroxide, okay, to this. Okay, now if I add relatively, so I have about 50 mils in here right now. If I add 50 more milliliters, what's going to happen?
It's gonna explode.
That's a safe assumption.
Good, it's gonna turn to water because they neutralize each other. Okay,
Is this
so
what she drank?
I'm gonna change the pH.
Yeah, well, yeah, but she'd actually drink it.
Wait a second.
Okay, so that's about at 7. Once again, it's probably not perfect because I'm not being that
She put
accurate.
some thing
But
in
now
there.
what I'm gonna do is I'm gonna add 24 mils, so I'm gonna push it now to make it, this is a base. And this has a pH of like 12.
Yeah,
You're gonna make it basic.
So now I'm gonna make it
yeah, basic. You guys seen The Good Place? Yeah, basic.
Okay, so now I'm gonna do the same to
Wait,
each
why
of our
is that one
beakers.
clear
Wait, they're
and
gonna be
it turns
different.
red?
Because there's like a thing that tells you, I can't think of the word. Dude, she
Oh, is
put a
it-
something.
Rainbow.
Indicator?
That's the word.
Rainbow.
He put different,
Rainbow.
Wait, this is amazing.
It's magical.
Now the question is,
You wanted like a different indicator for each one.
Now it's gonna be green.
no,
he put different buffers in each one.
Roy G. Biv.
I feel like it's the same
Oh,
exact
it's the
color.
same
color.
It's
the
not as
same
pretty as it's
color.
supposed to look.
There
Oh.
you
Yes.
Blue, I'm calling it.
How did I know? I'm too good.
It's perfect.
Wow.
Wow.
Wow, I'm so proud of you.
That is a good one.
Wow.
That is, yeah, that's a good idea.
Now drink them.
Now we're gonna die.
Okay, now, second question, don't say it out loud, but for a smiley face. Are these at the same or different pHs relatively speaking?
Wait, so what's the difference between each of them? Like,
Put a different indicator.
different indicator or different?
That's my guess.
So I added 50 mils of HCl and 75 mils of NaOH to each of them. Are they
Yeah,
the same
except-
pH or different pHs?
But you added the same amount of each thing.
Except for the green one. The green one looks like
That's,
S4.
that one does have a little bit more.
Okay, cool.
Okay, thumbs up, same, thumbs down, different.
Wait.
If they're
You can't
all-
see what I'm doing. Except if you look
We'll
at
say
the
assume they're all at the
position of
exact
my
same
wrist.
level. Would the pHs be the same?
I just want it to be so
You
bad.
feel like they should be, but at the same time, it's like, it's chemistry, it's probably not.
Yeah, exactly. This is a hopeful, optimistic thumbs up.
Okay, you
Did
can
you
all
just
have
say
a
my
smiley
mom
face.
is an optimistic thumbs up?